Okay, in this video we're going to be beginning chapter 7 that deals with probability, living with the odds. And section 7a deals with the fundamentals of probability. Okay, here probability plays such a huge role in our lives that it is essential to understand how it works. In this unit we will discuss the fundamental concepts required for probability calculations. So here I'm going to give you a few definitions to start off with. Alright, outcomes are the most basic possible results of observations or experiments. For example, if you toss two coins, one possible outcome is HT, as heads and then tails, and another possible outcome is TH, tails then heads. Now, an event consists of one or more outcomes that share a property of interest. For example, if you toss two coins and count the number of heads, then the outcomes HT and TH both represent the same event of one head and one tail. So here, this is an illustration of all the possible outcomes if you toss two coins. Okay? This could be one possible outcome. Just two tails. So the event would be 0 heads. And then another possible outcome would be the first coin is a tail, the second one is head. So the event would be one head, or another outcome would be this. The first coin is a head, and the second coin is tails. So one head would be an event, and then here you got two heads here on the first and the second coin. So two heads will be your event. Okay? Now let's look at an example of listing all the possible outcomes. Let's say we describe the weather as either clear, which is C, or frigid, which will be F. Answer parts A and B below. In this case here, in part A, we're going to be using the letters C and F to list all the possible outcomes for the weather on 2 consecutive days. Okay? The way I would do this is create a tree diagram with branches here. So, I'm going to put A down here since I don't have enough room. So, for the first day, it could be either clear, or frigid, F. Now, on the second day, if the first day is clear, the second day could be clear, or the second day could be frigid. Now, if the first day is frigid, then the second day could be clear, or frigid. And if you look at your possible outcomes here, we got C to C, and then next will be C to F, and then another one from F to C, and then the final F to F. So here, these are all the possible outcomes for the weather on 2 consecutive days. Okay, so that's part A. Now part B, if we are only interested in the number of C, or the number of clear days, what are the possible events for the 2 consecutive days? Okay. What would be the possible outcomes for the 2 consecutive days if we were interested in the number of clear days? Okay. So here, if we have frigid and frigid, there are no clear days. Here's one clear day right here. So I'm going to put 0 for no clear days. And these two each have one clear day here. And this one has 2 clear days. So here, the possible events will be 0, 1, or 2. Just like if we were rolling tossing 2 coins. Okay. Okay, let's talk about how to express probability. The probability of an event expressed as this notation, P with the, let's say with the word event inside the parentheses, the probability of an event occurring is always going to be between 0 and 1 inclusive. So in this case here, the probability of event A is greater than or equal to 0 and less than or equal to 1. Now, if we have a probability of 0, that means that the event will be impossible. And if you have a probability of exactly 1, that means your event will be certain. Okay? And here's an illustration of that. In this case, a certain event is where your probability is going to be 1. An impossible event will be where your probability is exactly 0. 0.5 means a 50-50 chance. And if it's between 0.5 and 1, then it's going to be a likely event. An unlikely event will be somewhere between 0 and 0.5. Okay. Alright, let's talk about the theoretical method for equally likely outcomes. Alright, there are 3 steps here. You're going to count the total number of possible outcomes. That would be step number 1. Step 2. Among all the possible outcomes, count the number of ways the event of interest, which is we're going to call A, can occur. And then step 3, determine the probability, which is going to be P with your A in the parentheses. So the probability of event A occurring will be the number of ways that event A can occur divided by the total number of outcomes. Okay, so in this example, number 2, sorry, I can't get all this on the screen. Use a theoretical method to determine the probability of the following outcome and event. State any assumptions made. And that is, in this case, tossing 2 coins and getting either 1 head or 2 tails. Okay, I like to draw that tree diagram. Okay, so the first toss could be a head or a tail. Now, if I get a head on the first coin, then the second coin could have either a head or a tail. Or if on the first coin is a tail, then the second coin could end up being head or tail. So all the possible outcomes would be this: a head and a head, head and a tail, tail then head, and finally tails and tails. Okay, so here we want to find out this: tossing 2 coins and getting either 1 head or 2 tails. And we want to find out what that probability is for 1 head or 2 tails. Well, here's a possibility where we got 2 heads here. Here's another possibility of getting 1 head or 2 tails. 1 head or 2 heads. This one we got 2, this one, and this one each has 1. So there are 3 possible ways that this can happen. But a tail and a tail doesn't have a head there at all. So it's going to be 3 out of 4. So that probability will be 3/4. And we're assuming that each coin is a fair coin and is equally likely to land heads or tails. So I'm picking this answer choice right here. Okay. Let's look at this next example. In this case, we're going to use a theoretical method to determine the probability of the given outcome or event. Assume that the die is fair. Let's talk about rolling a single six-sided die and getting a 1 or a 6. Okay, let's look at the possibilities here. The probability of getting a 1 on a six-sided die. Well, there's only one way to get a 1, okay? Because the die has 6 numbers, 1, 2, 3, 4, 5, and 6. Okay, so it'll be 1 out of 6. And the probability of getting a 6, again, that's also 1 out of 6. Okay, because on a single-sided die, on a single six-sided die, you have these 6 possibilities. 1, 2, 3, 4, 5, and 6. Okay, and now let's find the probability of getting a 1 or a 6. What I'll do here is add these two probabilities together. The probability of getting a 1 plus the probability of getting a 6. Well, the probability of getting a 1 will be 1 out of 6. Plus the probability of getting a 6 will be also 1 out of 6. Well, if I add 1 6 and 1 6, I'm going to get 2 over 6. Reduce 2 6 by dividing the numerator and the denominator by 2, you're going to get 1/3. So the probability of getting 1 or 6 would be 1/3. Alright, let's look at this next example. Determine the probability of selecting a 2-child family with 2 girls, assuming boys and girls are equally likely. Here the probability of selecting a 2-child family with 2 girls. Okay, so I'm going to draw that tree diagram. So the first child could be either a boy or a girl. And if the first child is a boy, then the second child could be either a boy or a girl. Or if the first child is a girl, the second child could be either boy or girl. So all of my possible outcomes are going to be this. Boy and then a boy, and then boy, then girl, and then girl, then boy, and then finally girl and girl. So we want the probability of getting 2 girls from a 2-child family. Well, there's only one way that you can get 2 girls, as you can see here. And that's out of 4 outcomes here. So the probability of getting exactly 2 girls here from a 2-child family will be 1/4. Okay, example 5. Use a theoretical method to determine the probability of the following event. A randomly selected person has a birthday in September. So I'm going to say here the probability of a birthday in September. Now, we have to think of this. How many days are there in September? In this case, they're 30 days, meaning that they're going to be 30 birthdays during the month of September. So it'll be 30 divided by, in this case here, there are 365 days in a year. So it'll be 30 divided by 365. Now, of course, we have to give this as a simplified fraction, meaning we need it reduced in its simplest form. So I'm going to divide the numerator and the denominator by 5. So if I do 30 divided by 5, that's going to be 6 over 365 divided by 5, that will be 73. So in simplest form, the probability of a randomly selected person that will have a birthday in September will be 6 out of 73. Okay. All right, next we'll look at the multiplication principle. I'm just going to do a short review of the multiplication principle. It states here, suppose there are m possible outcomes for one process and n possible outcomes for the second process. The total number of possible outcomes for the two processes combined would be m times n. Okay, so we just multiply those possible outcomes together. Okay, like in this example here, example 6. How many different choices of car does a person have if a particular model comes in 6 colors and 3 styles, hatchback, sedan, or midsize SUV? Well, there are 6 colors, and we're going to multiply that by the 3 styles. So it's just simply 6 times 3, which is 18. So here there are 18 different choices of car. Okay. All right, here's another example of the multiplication principle. Pizza House offers 4 different salads, 4 different kinds of pizza, and 5 different desserts. How many different 3-course meals can be ordered? Well, we got 4 different kinds of, 4 different salads. We're going to multiply that by 4 different kinds of pizza times 5 different desserts. If you multiply 4 times 4, that will give you 16. 16 times 5 will give you 80. So here we have 80 different 3-course meals that can be ordered. Okay. All right, now let's talk about relative frequency probabilities. This is the second way to determine probabilities, is to approximate the probability of an event A by making many observations and counting the number of times event A occurs. This approach is called the relative frequency method. Sometimes it's called the empirical method. So here, the probability of event A occurring will be the number of times that event A occurred divided by the total number of observations. So let's say we have something like this. Here's example 8. A local weather forecast has been accurate for 21 of the past 38 days. Based on this fact, what is the relative frequency probability that the forecast for tomorrow will be accurate? Okay, so here they're telling us this. So here we want the probability of an accurate forecast on tomorrow. In this case here, it's been accurate for 21 days out of the past 38 days. So just take 21 and divide that by 38. And we're going to round to the nearest thousand. In other words, to 3 decimal places. So in this case, we're doing 21 divided by 38. And the 3 decimal places, as you can see here, the third number after the decimal point is a 2. To the right of it is a 6. It's bigger than 5, so we increase the 2 to a 3. So in this case, this will be 0.553. Take out, excuse me. .553. So the probability that the forecast for tomorrow will be accurate will be 0.553. Okay. All right, here's the next example. Halfway through the season, a soccer player has made 11 penalty kicks in 17 attempts. Based on her performance to date, what is the relative frequency probability that she will make her next penalty kick? So here the probability of, let's say, making the next penalty kick. Well, she made 11 penalty kicks out of 17. So we do 11 divided by 17, and again we're going to round to the nearest thousand, or to the nearest whole number. So the 11 divided by 17. Okay, the 7 is the third number after the decimal point. To the right of it is a 0, that's less than 5. So that 7 remains the same. So it'll be 0.647. So the probability of making the next penalty kick will be 0.647. Alright, here's the next example. You toss a coin 200 times and get 190 heads. Complete parts A through C below. Here we're going to determine the relative frequency probability. Okay? So the probability of getting a head when you toss a coin 200 times, that's going to be 190 divided by 200. And in this case here, if I do 190 divided by 200, that will be 0.95. And here I think they want this as a decimal, so I'm going to say 0.95. That's the relative frequency probability of getting a head. Determine the expected frequency of the event. Well, in this case, if you toss a single coin one time, that probability of getting a head on that one single toss will have to be 1 out of 2. Or, if you do 1 divided by 2, that's going to be 0.5. Okay? Now part C is, do you have reason to expect the coin is unfair? And explain. Well, if you look at the probability of getting a head after tossing a coin 200 times, and you get a probability of 0.95, that would raise some suspicion that that coin is unfair. because that relative frequency is not near the expected frequency. Okay. All right, next we'll look at subjective probabilities. Now, already we talked about two different types of probability, or two approaches for finding the probability. One of them, of course, is the theoretical probability, which is based on the assumption that all outcomes are equally likely. And it is determined by dividing the number of ways an event can occur by the total number of possible outcomes. A relative frequency probability based on observations or experiments is going to be the relative frequency of the event of interest. Now, for a subjective probability, that's just going to be an estimate based on experience or intuition. One example I can think of a subjective probability would be a few years back when I was teaching two sections of math for elementary teachers, part 1 and part 2. In the first part, I will have probably 16 students enrolled in that class. The following semester, I will have about 8 students enrolled. So that subjective probability would be something like 1/2 for someone who took math for teachers 1 and then go on to take the second part the following semester. Okay. Now, in example 11, here we're going to state which method, either theoretical, relative frequency, or subjective, should be used to answer the question below. What is the probability of being dealt a pair of kings in a 5-card hand? Probability of being dealt a pair of kings in a 5-card hand. Now, in this case here, a relative frequency is not something like when you're tossing a fair coin a certain number of times here. But here, we have to think of it as a theoretical probability. Okay, because in a theoretical probability, we look at the number of ways that an event can occur. In this case here, we need to look at all the possible hands with a pair of kings. We have to count all the possible hands with a pair of kings. And keep in mind, in the homework, they're going to give you a drop-down menu to select those answer choices. Okay, next we'll look at probability of an event not occurring. If the probability of an event A, or P of A, we write the probability that event A does not occur as P not A. Probability of not A occurring, because an event either does occur or does not occur. The sum of these probabilities is probability of event A plus the probability of not A equals to 1. Therefore, the probability of that event A does not occur will be this. The probability of not A equals 1 minus the probability of event A. Now, we usually call that the complement. So that complement would be the probability of not A occurring. So here we call that the complement of A. And sometimes they use the A with a bar to indicate the complement of event A as its notation. Alright, in example 12, determine the probability of the given opposite event. What is the probability of rolling a fair die and not getting an outcome less than 2? Okay, now let's look at this. the probability of getting an outcome less than 2, well, less than 2 means if we're rolling a fair die, anything less than 2 will have to be just the 1. So the probability of getting a 1 will have to be 1 out of 6 because there's only 1, 2, 3, 4, 5, and 6 on a single die. So if I want to find the probability of not getting a 1, that will be 1 minus the probability of getting a 1. Okay? Because getting a 1 and not getting a 1, those are complements of each other. And I know the probability of getting a 1 would be 1 out of 6. So if I do 1 minus 1/6, and I'm going to show you how to do fractions on this calculator here. So if I do 1 minus, and I'm going to do left parentheses, 1 divided by 6, you'll get the decimal part, but they want that as a simplified fraction. So here, to do that, we're going to press this button that says Math on the left-hand side. You'll get this menu, and under the Math menu, you're going to select number 1 for fraction. And then hit Enter. This will give you 5 over 6. Okay? So 1 minus 1/6 will be 5/6. So the probability of rolling a fair die and not getting an outcome less than 2 would be 5 over 6. Okay. Okay, let's look at another example that deals with the opposite event. What's the probability that a 60% free throw shooter will miss her next free throw? Okay. So in this case here, the probability of getting a free throw that's 60%. But 60% as a decimal will be 0.60, or you can say 0.6 if you want to. You take 60 divided by 100, you'll get the decimal when you change a percent to a decimal. Now, missing a free throw would be the opposite of making a free throw. So the probability of missing a free throw, that's 1 minus the probability of getting a free throw. So in this case here, this will be 1 minus 0.60 or 0.40. And I think 0.4 would suffice here. So the probability that a 60% free throw shooter would miss her next free throw would be 0.4. Okay. All right, next we'll look at probability distributions here. Once we find probabilities for certain events, we can summarize them with a probability distribution that displays every possible event of interest. And here's how we make a probability distribution. Well, let's define that first. A probability distribution represents the probabilities of all possible events. To make a probability distribution, you're going to do the following. You're going to list all the possible outcomes. You might have to use a table or a figure if it is helpful to you. Step number 2, identify outcomes that represent the same event and determine the probability of each event. And then step number 3, make a table listing for each event and its probability. The sum of all the probabilities must be 1. Okay. Now, an example of doing a probability distribution would be something like this. Let's say we have a 2 dice distribution here. A 2 dice distribution. You're going to make a probability distribution for the sum of the dice when 2 paired dice are rolled together. What is the most probable sum? Well, you have to look at it this way. There are 6 ways for each dice to land. So, there are going to be 6 times 6, or 36 possible outcomes for a single roll of the 2 dice. Because one die has 6 possible ways, the second one has 6 possible ways. So, multiply those two, you'll get 36 possible outcomes. And here is the list of all the possible outcomes here, from 2 all the way to 12. That's the listing right there. Now, on the next page I'm going to show you, they condensed all of that into a single probability distribution, as you're about to see. Here it is. You're going to make a probability distribution for the sum of the dice when 2 paired dice are rolled together. And then we can find out what is the most probable sum. Okay? And then listed this from 2 all the way up to 12. For 2, there's only one possible way out of 36. And that's the 1 and the 1. For the roll of 3, there's only 2 possible ways. A 1 and a 2, and a 2 and a 1, as you can see. And we carry that on all the way out here, just count up how many ways to get a 4, how many ways to get a 5, and so on. Now you can see here, though, if we add up all these probabilities together, they have to be equal to 1. And now, what will be the most probable sum? I'm looking at the number 7, because that probability is 6 out of 36, or in simplest form, 1 out of 6. Okay? That's the most likely event is going to be the sum of 7, and that occurs for 6 of the 36 outcomes. Okay, next we'll look at stating the odds. Odds are the ratio of the probability that a particular event will occur to the probability that it will not occur. Now here we got odds for an event, and also we got odds against an event. When we're finding the odds for an event, or the odds in favor of an event, it's going to be the probability that event A will occur divided by the probability that A would not occur. And then for the odds against event A, notice you got this. Odds against us going to be the probability where A does not occur divided by the probability of event A occur. Notice here, the odds against that probability is the reciprocal for the odds in favor of. So once you know what the odds in favor of, you want to find out what the odds against, we just take the reciprocal of that. Now in gambling, the term odds on generally means odds against. Sometimes you may see the words odds on. That just simply means odds against, especially in gambling. Okay, let's look at this example here. Find the odds for and the odds against the event rolling a fair die and getting a 4, a 5, or 2. So in part A, we're going to find the odds for the event. We need to first find out what the probability is of getting a 4, or a 5, or a 2. I'm going to find out the probability of getting a 4 plus the probability of getting a 5 plus the probability of getting a 6. Now, to get a 4, if you're rolling a fair die, a single fair die, there's only one way to get a 4, so that probability of a 4 is 1/6. The probability of getting a 5, also 1/6. The probability of getting a 6, also 1/6. And I need to make a correction here. This should be a probability of getting a 2. And there's only one way to get a 2, so it's still 1 out of 6. Okay, so add 1/6, 1/6, and 1/6, you're going to get 3/6. Reduce that in simplest form, dividing the numerator and the denominator by 3, it will be 1/2. So the probability of getting a 4, a 5, or a 2 would be 1/2. Now what about the probability of not getting a 4, or a 5, or a 2? That's the complement. So it'll be 1 minus the probability of a 4, or a 5, or a 2. And we found that out to be 1/2. So if I do 1 minus a half, you're going to get 1/2. Okay. Now we're going to use that to find the odds for that event. So the odds for getting a 4, or a 5, or a 2 would be the probability of getting a 4, or 5, or 2 divided by the probability of not getting a 4, or 5, or 2. The probability of getting a 4, or 5, or 2 will be 1/2 divided by the probability of not getting a 4, or 5, or 2. That's 1/2. Now if I do 1/2 divided by 1/2, when we divide fractions, we have to multiply by the reciprocal of 1/2 in the denominator, which is going to be 2. So if I do 1/2 times 2/1, this will be 2/2. Reduce that, will be 1/1. So the odds for the event are 1 to 1. Okay, 1 to 1. Now part B, we want the odds against. So the odds against that event happening, well, pretty much we just take the reciprocal of the odds for, because I did tell you that the odds against is the reciprocal of odds for. So if I do the reciprocal of 1/1, that's still going to be 1/1. So the odds against the event are 1 to 1. 1 to 1. Okay. Alright, here's the last example in this video. The odds on, or the odds against, your bet are 1 to 3. If you bet $6 and win, how much will you gain? Okay, now let's think about this for a moment here. The odds against that bet, or the odds on, especially in gambling, are 3 to 1. What that means is this. For every $3 that you bet, every $3 that you bet, you can win $1. So you're only going to win $1 for every $3 that you bet. Okay? So let's find out how much will you gain if you bet $6 here. And the way I'm going to have to do this is write this as a proportion. $3 that you bet, you win $1. So the amount of the bet will be over the amount that you can win. That's going to be equivalent to, here we're betting $6 and we win. and 6 goes here, and we're trying to find out how much we can gain. I'm going to let x be that. So here I have a proportion that I can solve here. If I cross multiply here, 3 times x, that's going to be 3x, equal to 1 times 6, that will be 6. So I have an equation, 3x is equal to 6. And to find out what x is, I'm multiplying by 3, I need to divide both sides by 3. So x will be equal to $2. So, if I bet $6 and win, I can gain $2 from this. Okay. Alright, so that will conclude this video on the fundamentals of probability.